All right. Well, I want to go into a little more detail with the fog issue that uh, we used in that underwater scene. Um, and a lot of this has to do with the flaws in the Unity fog, default fog. If you go into the lighting window down near the bottom, there's a toggle for fog. It has three different types, linear, exponential, and exponential squared. These are each options that determine how the fog density varies with distance. Linear lets you define a start and an end distance. Start is how far in front of the camera the fog begins to obscure the view, and end is how far away it becomes completely opaque. Exponential and exponential squared are, as you would expect, exponential functions that fall off with an exponential curve. And these have an exponent which determines uh, how that fog falls off with distance. Typical values less than zero point 0.1 give pretty reasonable results. And the problem with the Unity default fog is, as I showed you back with the water, that it only appears in front of opaque objects, and it doesn't interact properly with the skybox. It's good for dungeons and caves and other underground things where you're not seeing the sky. And so it looks like this. These are simple scenes with not a lot going on in them. I've got stuff to look at far away, and I've got a ramp so that I can climb up and see things. And if I press 1, it now switches to the default fog. So, and I've made the fog red to kind of accentuate its difference. So you can see that it's putting red stuff in front of things. And as you get closer to the things, the red stuff becomes less and less intense until you get right up to it, and then it disappears. So, uh, um, so that's a problem with the Unity default fog. Unity's current solution to this problem is to use the post-processing stack. An earlier version of the stack, I think version 1, had as one of its effects something called deferred fog. But it has disappeared from the Unity effects in the post-processing stack. And it's still there in a way, but it's a very awkward combination of default fog and the stack. And it no longer is like all the other effects. It's different, and its settings appear someplace else. It's kind of cobbled. Um, Also, to get it to work is a little arcane, because you basically have to go through the whole process of setting up the post-processing stack, even though it's not a post-processing stack effect. So to get it to work, you have to enable the fog in the lighting window. Even if you're using this post-processing stack, you still have to turn fog on in the lighting window and set all its settings there for whether you want linear, exponential, or exponential squared. You need to create a post-process volume. This was the trick we used to have the fog below the water level back in the water. And we can, in this case, set it to be global. As I mentioned, you can have a collider that determines its range, but it also has a global setting, in which case it's available everywhere. You need to create a post-process profile. And this post-process profile may have no other effects unless you want them. And this is what we insert in the slot of the post-process volume that we just created up here in step B. We have to add a post-process layer to the camera that will see the fog. This camera's rendering path has to be deferred. This is called deferred fog, and it only happens with the deferred renderer. There's the forward renderer and the deferred renderer. Um, and uh, having done this, this is also where you enable deferred fog. So we had to enable fog up here, and we have to enable deferred fog down here on this post-processing layer. There's an option to exclude the skybox, but don't use it, because if you do, it looks just like the default fog. And one other point is that the post-processing volume that we set up here needs to be in its own layer. This is the warning tells you that if you don't do this, it runs much slower and interferes with the blending process. And in that post-process layer, there's a slot where you tell it what layer its post-processing volume is in. So, whoop-de-doo, here's what that looks like. It's, you know, a perfectly decent fog that declines with distance. It doesn't show the skybox the way that the default one does. It attenuates our visibility with distance, and so it works great. That's fine. I prefer this older approach from the pre-stack era, Unity 5. It was once a standard asset, but they took it out of the standard assets in 5.6 and put it on the asset store, and now it's no longer on the asset store, so I guess it's gone. I have a copy of it, and I'll distribute it with this lecture. But within it is this global fog script that attaches as a component to a camera that is to see fog. So it's a much simpler process. You do still need to enable fog in the lighting window, but we only have one script that we put on the camera, and that's all the fiddle that we have to do with it. It has options for distance fog, which is what we're seeing here. The distance fog, I believe, is global fog distance, so that's item number 2. And this looks a lot like the post-processing fog. They're not a lot different. I believe they have slightly different attenuations. But other than that, they look pretty much the same. But what's kind of cool is this height option, the height above which the fog disappears. And so the height, this is global fog with height. And so down here at ground level, I'm seeing off in the distance. If I look up, though, the fog thins with elevation. And if I go up on this ramp, I can get up out of the fog, and I can look out across the landscape where these towers are poking up through the fog. So that's all pretty cool. And these are all just simple settings in the global fog script. We set the height, how high we want the fog above the ground, the height density that determines its thickness, as well as a start distance, which I believe kind of overrides the start distance in the lighting windows fog. It also has an exclude far pixels that disables the fog in front of the skybox, but again, don't do that. Here are all my different fogs. Here we are with no fog, Unity fog, global fog with distance, global fog with height. Oh, and I didn't show you this one. This is global fog with both height and distance. So now if I go up here, I can see the fog is kind of thicker down at ground level on these towers, but there is a global fog all around me that's attenuating the visibility. And finally, the processing stack fog, which I don't think is as versatile as the global fog script. Maybe that it's more efficient, and that might be the issue for why they went to the stack. But anyway, um, so that's that. I'm going to stop sharing here at this point, and I'm going to end the recording, and I'll see you all in class. Bye.